Hi everybody, how are you? Hope everybody's doing well. Hopefully this will help a little bit. I'm going to post these notes for you so you can read through them, and then hopefully follow along with the video while I do a couple of the problems out for you. I've done number 3 out for you in 2 different ways. I tried using the scaffolding to show you guys instead of my immersion techniques as usual, with the color coding scheme. So try to go through that and take a look at those before you really go any further with the problem sets, okay, when the problems that we go over right about now. Okay, so we're going to go over this problem right here. This is problem number 5. It says solve the equation for the specified variable. Woo, the variable here. So the original equation is capital Y equals capital D capital C minus 3. And we have to solve for capital D. So, as always, what I'm trying to say is rewrite the equation so you have a nice fresh place to start. And then what you want to do is kind of read what is being said here and identify where the variable of interest is. In this case, it's going to definitely be on the right-hand side, right? So the right-hand side has the variable of interest. Well, if we have that equaling our left-hand side, for example, then we have to kind of remember that little visual we had back in lecture a little while ago with the pen and the body being the equal sign, and holding the pen in one of your hands, either in your right hand or your left hand. And remember, the orientation matters. And if it's in the right hand and it goes to the left, if it was pointing up, it'll go down. So opposite sides are opposite operations or signs. These are the inverses. So you're literally reading what is on the right-hand side and doing the exact inverse to the left-hand side from what the right-hand side is saying. So in this case, I like this problem because it kind of gets you focused on reminding you about slopes and y-intercept form. And it kind of almost looks like y equals mx plus b if you try to visualize that. So what I'm going to do is I'm just going to look at the right-hand side for a second, and I'm just going to pull it out over here and just, I don't want to pull that out there. Just pull this out right here, and all I want to do is read that as it stands. And it says d times c minus 3. Now, you could also read it another way, but let's just go with this for just 1 second. The product of d and c minus 3, or d times c minus 3. So, what's the opposite or the inverse of a negative 3? Well, yeah, you got it. It's a positive 3. And what's the opposite of multiplying by c? You got it. Dividing by c. So, if we write this just directly, it says what? It says d times c, then subtract, just move that, subtract 3. So the inverse of that might be what? Add 3, then divide by what? We want to get the d isolated. So in this case, we would divide both sides by c. So let's do that out, and we'll just remind you guys about the typical way that we look at it. And there we go. Here we go. Let me just copy this real quick and put it down here. And I'm hoping you can see those steps. So I'm going to use the magenta here first. So I'm going to add 3, right? Because we're working in reverse PEMDAS almost, right? Doesn't always happen to be the case, but we try to have that. So I'm going to plus 3. Now, if we add 3 to both sides, you can see clearly that I have a 0 over here. And that's one of the reasons why I do the opposite sides or opposite operations or signs, is so I technically don't have to really think about that 0 at all. I'm actually reading and doing the inverse. Much like if you go from a ship to a treasure map, and you get off the ship and you try to follow the treasure map all the way to a treasure, you need to know how to get back to the ship if you want to be able to spend that money. So, and we talked about that in class before. So, I add 3 to both sides. Okay, well, what's on the left-hand side? Well, that's just going to be the y plus 3. Why can't we say there's 3y or something to that effect is because y could be any number, and we're adding that to 3. Another way to say it is that you cannot add the old apples and oranges. In this case, y is maybe an apple and 3 is maybe an orange. And although you might be able to add them together and call them apple jizz or something to that effect, we don't usually have a term for that. So I'm going to put this back here as D and then C. And then you can see that what we do here is we divide both sides by C. And when we do that, we'll get something to the effect of y plus 3 divided by C equals D. Now, remember, you can simplify this very quickly by just taking whatever is in the numerator, whatever term is in the numerator. And remember, in this numerator, we have 2 terms. So, I'm just going to take each one of those terms, in this case y and 3, and divide them both by c. And in this case, we're going to have y divided by c, let me erase that, plus what? 3 divided by c, which equals d. And this is, guess what, the same gosh darn thing as 1 over c times y plus 1 over c times 3 is equal to d. Those are the same gosh darn things, okay? And I know fractions may look scary, but guess what? They're not that bad, okay? So let's move on to the next one. And now we have to look at this other problem where we have to factor first. And the reason I know that it has to do with factoring is because I see the same variable in multiple terms. You see, I have, well, let's go through it in a second. So this is problem 6, and we're going to solve the equation for the specified variable. And the equation is s equals yr minus 4yk squared. And we have to solve for y. So I rewrote the problem, and I'm trying to identify the variable interest. The key thing that comes to mind is I see 2 y's in 2 terms. So that means I can take one of those y's, one of those y terms, from each one of those major terms. In this case, the yr and the 4yk squared. Now that may sound a little complicated, but do you see 2 y's? Take one of them out. And what you're really doing is factoring, but you're sort of reverse distribution or reverse distributing the y. And it's not really correct to say that, but it does help kind of remind you about what you're doing, because if I multiply those back, I get this thing right there. So, now that we have y times some beast here, this is a whole beast. This is one number. We don't know what this crazy expression of a number is. We have no clue what it is. But it could be 5, it could be 6, it could be 7, it could be 10. It could be a lot of other things too. But the essence of it is, it's one entire number. And how do you know that? Because it's grouped with parentheses. Those parentheses group it together as one number. So, could be like 2 plus 3 is 5. In this case, we have r minus 4k squared, but a little different. So I put it back there, and now I look at what's going on between the variable of interest that I have and what I want to get rid of. And what I clearly want to get rid of is that quantity of the r minus 4k, this right here. We want to get rid of that. Why? Because we want to get the y alone. They always say mathematicians are looking for x and y, and they can never find. But, we're actually looking for a lot more. So I hope you guys are having a little bit of fun. Anyway, what we're going to do here is we're going to divide both sides here by what? Because what would make a factor of 1 here? We need to just cross out or cancel something that needs to go in order to get y. Yeah, you got it. I'm just talking. So here you go. So I divided both sides by that grouping, that number that's grouped into two pieces. And remember, it's a combination. Okay, we'll talk more about that later. But this is s divided by r minus 4k squared, and this is sufficient. However, you could also represent it as this, s divided by, oh, guess what? R minus 4k squared. Kind of just having fun, because what I'm trying to illustrate here is, do you see how there's only one term? Notice in the other one when we did this, we had two terms. You see them again? Two terms. I'm trying to get you to see that we're not making any of these crazy little rules or laws or properties for any reason. We're saying one number divided by another number instead of two numbers that are divided by one number, which is what this is saying right here, right? The sum of two things, and take that and divide it by some other number. So we have a quotient. Okay. So I hope you had a little bit of fun with that. Anyway, here we go. And that's our answer. We should make a happy little tree over here or something, right? It's a happy little tree. It's a horrible tree, but anyway. So let's move on to the next problem. Now we have problem 7. And this is, again, much like we had in the last problem. In this case, we have to solve for b, which is inside that grouping. So it could be like 2 plus the product of 3 times 5. And we want to read it as such, because we don't want to just read it as 2 plus a times b. But we do want to have that understanding of what the expression is saying, because we can always just work in reverse. And that's one of the key things that I want you guys to keep remembering. So you can see here that we have a group. And that group happens to have the variable that we want. So we're going to keep it there. We are literally going to keep it there. So I rewrote the original equation, and I color coordinated the b. Now, that's the variable that we're going to isolate. That's the one we want to keep where it is because it's positive, and that's a key. You want to solve for the positive variable. So let me make a note of that. Always solve for the positive variable. Okay, just as a little reminder. So in this case, I'm just going to recopy it here just so I have a little bit of stuff to work with instead of making that a little bit messy. And see how I have that. Let's do it this way. Not red, because that's the same color. How about this dark purple? So here's the left-hand side of the equal sign, and here's the right-hand side of the equal sign. Notice that I have this c times this monstrosity, this term, this grouping of a number, a sum of a number, really. So it says some number times c. I'm just reading it sort of in reverse. some number which I don't know times this variable c, which I also don't know. So I'm going to divide both sides by c, and that way I can cross out those c's, right? There's your factor of 1. So I get t over c, or t divided by c, equals 2 plus a, and I'll color that again as b. So I just keep it a little more structured this time. You can see I'm trying to keep you guys on the immersion focus so that you're not just reading some scaffolding. You're trying to make some other, maybe you could think of a different way to solve this. And I won't give you a clue, but distribution might be another way to do it. So, and now what do I have to do? I'm going to isolate this variable b. So I've got to get rid of a couple things. In this case, I've got to, and I know it's not exactly the best way to say it, but we have to get rid of the 2 and a. So we look at the operations that are going on there, and we just simply ask, what's going on between the a and the b? Well, that's multiplication. That's pretty strong as an operation. And then we have it being added to 2, which is also a positive. Oh, okay. So if we look at PEMDAS, again, just as a little reminder, and we realize that the addition and subtractions are weaker than the multiplication and divisions and work backwards, I'm going to subtract what from both sides? I hope you got it, the 2. So I'm going to subtract 2 from both sides, because that's weaker than multiplication between the a and the b. Minus 2 equals a, and I'll keep that color coordination this time, just so you can see it. And now I've got that monstrosity. But remember, in order to combine fractions, and yes, combine, not just add or subtract, but combine. That's the word you want to use. Combine. Okay, not just add or subtract. It is the same as add or subtract. Okay? Either one of those, if you're adding or subtracting, you are combining one way or another. And remember, we went through that before with you're adding negatives, you're really subtracting. So if you're really subtracting a number, you're adding a negative. So let's make common denominators here. So what I'm going to do is I'm just going to recopy this over here just a little bit to clean up my space, so hopefully somebody else could read this if they were going through the process. So I'm going to move this over just a little bit, and then I'm going to realize that the denominator here is just c. So I'm going to maybe put a 1 underneath. Now technically you don't really need to do that. You can take the cheap way and sort of say it this way. I'm going to take c and divide it by c that way. And now you see that there's a common denominator of c, because they're the same letter. They're the same variable. So this is t minus 2c, all divided by what? C. And all of that is going to equal a times b. So we're using a lot of our old techniques from way back when, like in 3rd, 4th, and 5th, and 6th, all the way through middle school, all the way to here, to just kind of work these symbols around and solve for them. And now you can see that there's only the a to get rid of. All you have to do now is ask, what's going on between the a and the b? What operation is going on between the a and the b? And do the opposite of that operation, the inverse of that operation. So when we do that, we divide both sides by a, and we get t minus 2c all divided by the product ac is equal to b. And this time, because we have the two terms, we can express this a little differently. We could take each term and divide it separately, right? So we could have something like this, and if we wanted to, we could even simplify this down to t over ac minus 2. So we see a lot of these little quirky things that we can work with. Technically, I believe the math lab program would probably want that one most likely as a solution. But again, when I look through them, I'll be taking a look to see how you know what you put in. Okay, here we go, problem 10, and then we have another thing here that we have to look at. Solve v equals m divided by 4, or 1/4 m, because when you divide a number by 2, you're taking 1/2 of that number. If you take a number and divide it by 3, you're dividing by that number. Or you're taking 1/3 of that number. If you take any number and divide it by 4, you're multiplying that number by 1/4. So remember how we did that before. If I take any number and divide it by 2, it's the same as 1/2 of that number. If I divide any number by 3, it's 1/3 that number. And if I take any number and divide it by 4, it's really that 4th one of that number. So I have this nice one. I recopied it. I isolated. Well, I didn't isolate. I color coordinated the variable of interest here that we want to solve for. And now I need to get something gone on the right-hand side. Okay, so here's the piece I need to get rid of, right? Because it is being multiplied by the beast right here, this other term. Oh, okay, but it's really one term. But just kind of think of them as two pieces of a big puzzle. And I have this product here that I'm multiplying this m divided by 4 times this, okay? So all I have to do is think about the reciprocal in this case, because if I use the reciprocal of m divided by 4, it's 4 divided by m, and that would cancel, or eliminate is a better word here, or create a factor of 1, which is the best way to say it, would allow you to get rid of that m divided by 4 and leave the c plus h on both sides. So opposite sides are opposite operations or signs. So 4 divided by m times v is then going to be equal to, and I won't write it out, but here's the c plus h. What I didn't want to write out was this piece over here, which was 4 over m times m over 4 is equal to 4m over 4m, which is 1, right? So now at this place, I can just change this to red now, sorry. And then we just have to do the inverse, or the opposite operation of what this is. Well, it's a positive what? C. So I can subtract it. Now we'll do that in a moment, but I want to rewrite that left-hand side just a bit. I'm going to say it's 4v divided by m. And the reason I can do that is because any number can be divided by 1. Now I'm hoping this makes a lot more sense when I do this. See, it's positive on the right, it's negative on the left. So 4v divided by m minus c equals h. I want to make the common denominators here. So I just do that. Why? Because m divided by m is 1. So this is 4v minus cm divided by m is equal to h. And this is probably what the math lab is looking for, primarily. A little fast, I hope it was a little okay. Now this one, I'm going to let you guys go through by yourselves, but this is one of the other problems on the problem set that I saw that a few people just didn't answer, and I think it might have just been because we've maybe forgot about the sets, and that's set notation. And all of these little beasties in here are called elements, right? So all of those numbers are the only solutions to whatever problem exists. Maybe it's in a computer and those are the only values that leads the program to somewhere else within the program. And so I rewrote the problem. I just wrote the problem. X minus 3 is less than or equal to 9. I solved it. We just subtracted 3 from both sides. So it's got to be less than or equal to 6. And the only choice was B, 3, 4, 5, and 6. I hope this helps. And guess what? Please don't give up on solving these. Sometimes they get a little bit difficult, but don't you give up. And if you're a Galaxy Quest fan, never give up, never surrender. On that note, have a great day. Bye.